now 3.2, graphing polynomial functions. So now we know, in fact, 3.1 and 3.2, this is both regarding how to graph, or as a matter of fact, we can say also sketch, because for the very detailed graphing, we won't be able to do it until we get to calculus. But in any case, I would further explain what is the what I meant here. In any case, so 3.2, based on the characteristics or the features that we talked about, the properties. You can use different words. I just always find the characteristics for spelling that bothers me. Characteristics of polynomial functions that we're going to use to sketch the graph. All right, so this is, I already mentioned in 3.1. So basically when we talked about the multiplicity, so this if one of the roots that is only the multiplicity of 1, so that means there's only one root as a, and then this is just across the x-axis. But if this has a multiplicity of an even number, so that means could be 2. So that means, in fact, there's a 2 roots, the same place of a, and then this bounces. Now, of course, this is a 4, same thing, right? It's an even number that just bounds. So there is no crossing. So this is, pay attention, this is even number. All right. Now, and then if it's an odd number, so such as 3 or 5, that means, so this is an odd number, it's greater than 1. So it's different. 1 is just a straight cross. Now here we talk about that it seems like it wants to bounce, however, it's being pushed through the x-axis. Same thing. This is going up, seems like it's going to bounce, and no, it changed the direction, it's cross the so it changed direction, means that it's going to cross the x-axis. All right, so now here, the summary here, that is just the characteristics that we all mentioned. Now they're saying this the step beside the first 2 steps, some of them could be, revised, depends on what you want to do. Now the first important thing, the first step is to find the x-intercepts, so that by solving the equation, so then, for example, the factoring, all right? So then we know that how many intercepts is along the x-axis. So now we're going to see how many intercepts. It could be one here, it could be another one here, it could be right here, doesn't matter, it could be right here, it could be right here. So all these there's x-intercepts. And now, of course, through graphing that either linear or quadratic, we have understood how important the y-intercept is, right? So where the graph would cross the y-axis at a certain point. So that's very important. Now this one, of course, that means solve for 1x equals to 0. So this one, of course, is y equals to 0 to give you the x-intercept. All right, so then determine the general shape at each intercept. So then we're going to use the multiplicity. If I use a big M, just not to be confused with the small m as a slope. So use the multiplicity of each intercept. Now, for example, if this is A, this is a B, this is a C, I just choose the 3 of them. So this is A, and this is B, and this is a C. All right? So now, for example, so that should be x minus A. Now, if this is nothing here means this is 1. So that means this is definitely, the graph will just be going through this, right? Going through this, either this way or this way. We don't know yet. Going through this one. Now, if we have the x subtract b, the power of 2 here, so then that means this would be, the shape will be either this, or the shape will be either this, right? Now, if we have this one here, if we got x subtract c, is that. Okay, well then we know it either will be like that, or will be like that, right? So then from here, you can just sketch the x-intercepts, figuring the turn or the bounces, how it happens as the intercepts. Now, this one, now we look at the coefficient of power or degree of the polynomial. So then we know either the end behavior is going to be like that, or going to be like that, right? Or end behavior will be going from up here all the way come down here, or going this way and all the way going up there. So then we're going to determine the end behavior. So as soon as you can determine the end behavior, then you can start going through these intercepts to see what's going on. Now here says also, now you can also, because if you go just from your end behavior, trying to go through these dots to verify with these curves, now you will know where it has to turn, right? But however, we can also determine the number of the turning points. Number of the turning points is number of the zeros minus 1 plus number of the even, right? Number of the even multiplicity. So in this case, if we have this 1, 2, 3, that means that we have 3 intercepts. So then that's 3 zeros, subtract 1, and how many even do we have? We have 1 even. So then that is 3. So here we would have 3 turning points. All right, so then you can start sketching this thing. This one is new here. So this one means like if I'm turning somewhere, how high do I reach in order to start turning? So this one I would use a example to explain. But here says use the x value between the x-intercept values, or between the x-intercepts, to estimate the highs and lows of the graph. All right? Now, this is, pay attention, this is estimate. Without using calculus, we can only estimate. Or, nowadays, I don't even think that that many people are really sketching the graph anymore. You can just use decimals. You don't even need to use graphing calculator, decimals. And then, of course, you can see the graph and you point your cursor to the lowest or highest point. It gives you the coordinates. And then plot a reasonable numbers of points and draw a smooth, continuous curve. So then, boys and girls, and of course, some of you would say, well, why don't I even bother? Why don't I just use the decimals? But the most important thing is that we needed to understand the characteristics of the polynomial functions, and so we don't just become a robot just to use software to graph. All right. Probably I stop here and then I make another video. I just wanted to keep it short.